It's a very long unit that I broke up into two. I think we have. Yeah. Yeah, these are the same. Yeah, that's cute. Did I really? Yeah. All right, so we wrapped up our Unit 0 kind of review intro unit yesterday. How did we think the tests went? Not bad? Pretty fair? You think the review looked very similar to the test? I told you guys, right? Okay. So they have been graded. They are in PowerSchool. If you have an opportunity to check at some point, you can see how you did. I passed out your homework from the section. That was graded on completion. So as long as you put forth a solid effort on every question, you got a 50 out of 50. Okay, if you left some questions blank, then I took some points off. Okay, so it's based on completion. Just as a reminder, if you completely finish, okay, your homework from the unit, you are eligible for that curve. Remember me talking or mentioning that at the beginning of the year? Okay, you have to turn in your homework on time, meaning the day of the unit test, and you have to have put forth a solid effort on every question. So if you did that, you were eligible for the test curve on the test that we took yesterday. If the curve was in your favor, I used it. For instance, some of you, or I'm just making this up, maybe you got a 92% actual on the test, but the curve, since you did all your homework, granted you a 95. Okay, I gave you a 95 since you did all your homework. Anything for the office this morning? I think we're good, honey. Thank you. Okay. So if the curve was in your favor, I used it. There are some instances, though, where you might score on the higher end of the curve. Maybe some of you actually got a 97% on the test, but depending on your score, you may have fallen or you may have fell within the 95% range. Okay, I'm not going to discredit you 2 percentage points because you fall within that curve range. Okay, so I only use the curve as long as it's in your favor, if that makes sense. Okay, again, that curve chart is on the syllabus if you want to see how that plays out. Okay, so we're going to start our first unit today. We're going to take a look at a lot of graphs in this section, analyzing how we read graphs, how we shift graphs, different types or names of graphs. Okay, and maybe you heard me mentioning how this is a very long unit, so I broke it up into two. This is Unit 1, Part 1. Okay, so we're going to start on page 29. Okay, you have the cover page with the little table on the front page. We're going to start on page 29. So what we're initially going to start with in this section is just getting used to how graphs are formed and how we can move them, meaning shifting them left, right, up, down. Maybe we flip them. Maybe we make them wider or skinnier. Okay, we're going to transform some graphs. And you guys were actually doing this in the unit we just covered. Remember those parabola U-shapes? And you use that vertex to like determine the equation, like if it moved left or right, up or down. Remember doing that? There were 4 at the bottom of your test. Okay, that was kind of an intro to what we're going to be doing in this unit. Okay, so many functions can be graphed by simply knowing a general shape. And what we're going to introduce or investigate is, well, what if we were to simply add a number or subtract a number? What if we were to throw in a negative somewhere? How do those simple changes affect the way a graph looks? Okay, so we're going to start with a square root graph initially. So we're going to use our calculator to help us see the transformations physically, but I want to go ahead and graph this first one by hand. Okay, if you wanted to graph a square root of x, what are some easy numbers that we can take the square root of? Good, Marie? 4. The square root of 4 is 2. So if you were to plug in 4, you would get out 2. We can plot that point. What are some easy numbers we can take the square root of? Specifically numbers that are on our graph. Notice how we only go out to 8. Anything else? Good, Rebecca? You do 1. The square root of 1 is 1. You plug in 1, you get out 1. Any other ones? What about the square root of 0? Alright, that's 0. What about the square root of some negative numbers? Bless you. Can you take the square root of negative numbers? Good, Maddie? Okay, no. So in terms of a graph, you could not graph the square root of negative numbers, but I believe you've had talked about in your previous math experiences that you can take the square root of a negative number. It's just imaginary, right? Okay, so we can't graph it, but we can still write an answer in terms of an imaginary number. So on a square root graph, we have no picture on the left-hand side where the negative numbers are. So this 0, 0 is kind of our starting point, and it looks like all the other points we have curve up and to the right. So what we're going to call this square root graph is our parent function. Okay, kind of the main graph that we start with. And based off of if we add something or subtract something, we're going to transform it. We're going to change it somehow. So this is referred to as the parent, whereas the transformations you can think of children. Okay, they're slightly different in some aspect. Okay, so let's go ahead and check out, well, what if we were to add 2 outside of that square root? We're going to see what happens on our graph. Okay, so turn it on. Let's go ahead into y equals, and we can clear out anything that's in there. We're going to type in the square root of x, but we want the plus 2 to be on the outside, so we have to make sure we arrow over to like end that square root bar, and we'll add 2. Okay? Now, before we hit graph, let's go ahead and change our window to make sure we can see what we want to see appropriately. What do you think our window should be? What do you think, Manny?
Can you go down on the graph?
Mm-hmm.
-10?
Okay, we can do the -10 to +10. That would be good. Notice how, though, if we're going to trace it on the graph in your notes, this one only goes from -8 to +8, right? In every direction. So you could do 10s, but if we're going to use this graph, let's maybe set it to that picture. -8, +8, counting by 1s. And we'll do that in every direction. Yeah?
Can you go, like, since you take down, like, the thing of square roots, can you go to that?
Yeah, you can go there. Notice how if I graph it, there's nothing there, okay? But if you want to chop it off, you can. Is that what you mean? Like, can you?
Like, could you make the line in 0?
Yeah, if you wanted to. I mean, we have this empty space here, so we don't need that. But personally, I'm not saying you have to do this, but personally, if this is the graph I'm going to be using to copy my graph, I want to make sure that this graph and this one match up so I can kind of draw it to scale. But if you want to cut off that empty space, you definitely can. Okay? So take a look at the graph based off the calculator. How do you think this parent function transformed? Can you describe the movement? What did that adding 2 on the end do to the graph? Good, Maddie?
It moved the starting point up 2.
it moved not only the starting point, but it moved every other point. Okay, so this is a shift up 2 units. So we're going to take every point on this parent function that we drew and just shift it up 2 units. Bless you. Maybe we can try the next one without our calculator. What do you think subtracting 2 on the end would do to this parent function? The original square root, yeah. Shift it down 2, okay? So if you wanted to investigate that on your calculator, go ahead. You could clear out the one we did before and you can type in the new one. But we're going to take the parent function and this time just shift every point down 2 spots. Okay, so all of these adding numbers, subtracting numbers within equations, they're actually affecting the way the graph looks. And that's what we're starting to investigate here. Okay, let's kind of switch it up at the bottom. This time, notice how we're adding 2 on the inside of the graph. Can we maybe anticipate before we check out on our calculator what you think this might do to the parent function, that original square root? What do you think, Rebecca? It's going to move the x value. Okay, notice how before, if we added or subtracted on the outside of the square root, it moved it up and down. So maybe we can anticipate if we add or subtract on the inside of the square root, it might move it left or right. Can we think about if we are adding 2, which way it might be moving? Right 2, left 2. You kind of got a 50-50 shot. What do you think, Tori? Let's see. Okay, let's go into our calculator. We'll clear out the one from before and we'll type in x plus 2. Same window, -8 to +8. So let's go ahead and hit graph. Which way did it move it? It moved it left. Okay, so this is what's a little tricky. Okay, when you are adding or subtracting a number on the inside of that square root, it's actually doing the opposite of what you would think it would. Okay, notice how that really didn't happen for the previous 2. If we added 2, it moved up. If we subtracted 2, it moved down. But the inside of a square root, and we're eventually talking about the inside portion of parentheses or whatever function we're working with, it's a little different. Okay, it does the opposite of what you think. So this one moved left 2 units. So we're going to take every point on that parent function and shift it to the left 2 spots. What do you think the next one's going to do? Can we make a connection? Good, Marie? Right 2, good. Alright, so take every point on that parent function and move it right 2. Do you notice how all these graphs have the same shape? Right? They all have that curve to them. They're just located in a different spot because you're transforming or moving them in some fashion. Okay, so we finished the adding and subtracting, whether it's on the inside or the outside. You're either moving it up or down or left or right, depending on the location. What do you think a negative might do to the graph? What do you think, Evan? Flip it? How? Okay, so we're going to flip, aka it's referred to as reflect. Okay. Over, now Evan guessed the x-axis. So just for an example here, okay, I'm going to draw, this is what the original parent graph looks like. You don't have to write this down if you don't want to. But notice how if I were to take this original parent graph and reflect it over the x-axis, it would now be upside down, right? You do a little folding. However, I could also take this original parent graph and possibly fold it over the y. Do you see how that might happen? Okay, so we have two ways that we can reflect or flip a graph. Evan was guessing over the x, meaning it's upside down. So let's go ahead and check out on our graph, on our calculator, if that's actually what happens. All right, so negative on the outside, and then the square root of x. And it looks like he was right. Do you see how it flipped upside down over that x-axis? So what you're going to do with your parent function is you're going to take every point, and instead of being maybe up 1 unit or up 2 units, you're now going to reflect that or flip it. So instead of being up 1 unit, you're now down 1 unit, and instead of being up 2, you're now down 2. You fold it over that x-axis. We doing okay? All right, we're going to check out a few more on the back. All right, so now we're going to amp it up a bit. What if we're doing two things in an equation? Okay, we've only been talking about one so far, but what if we're trying to do two? Okay, take a look at G. We're multiplying by 2 on the outside, because that was not a part of the parent or original function. And notice how we have a negative x on the inside this time. So we have two transformations. Can we maybe think about or anticipate what the 2 might do to the graph and what the negative on the inside might do? What do you think, Rachel? Okay, so we have a reflection or a flip over the y-axis. Okay, that's what the negative on the inside is doing, because we just saw in the last example the negative on the outside reflected it over the x. This negative is in a different spot, so it must be reflecting it in a different way. So this is over the x. What do you think the 2 is going to do? Notice how you're multiplying by 2? If you multiply by 2, aren't you doubling a value? Okay, so how do you think that's going to affect the graph? What are you doubling? Do you think we're doubling the length? Okay, like left and right. Do you think we're going to double the height? Kind of like an accordion, are we going to stretch it left and right, or are we going to stretch it up and down? How are we doubling the graph? Can we make a guess? Yeah. Vertically? Let's see. Okay. So maybe we have a vertical, we'll say stretch of 2. Okay, we're doubling it. So let's see what the graph looks like. 2 square root, of negative x. Alright, so it definitely flipped it across the y. Instead of being on the right side, it's now on the left, right? And notice how the curve kind of is higher than it normally was, which means you were stretching it vertically. You made it taller. So let's go ahead and see if we can plot these points. Now, if we were to reflect it just over the y-axis, we would have that beginning point at the origin. We would now have -1, +1 coordinate, and then -4, +2. Okay, that's if we just reflected it, right? But if we're vertically stretching it, these points have to be doubled. Their heights have to be doubled. Now this point at the origin has a height of 0, and if you double 0, that's not going to change, right? It's just going to stay where it is. But the next point has a height of 1. If you double 1, it's now at 2. The next point we had a height of 2, and if we double that, we're now at 4. So you're making your graph a little taller. You're stretching it with that multiplication out front. Can we see that? Okay. What about the next one? We have a negative x on the inside, and we're subtracting 2. Can we take some guesses as to what the graph might look like, how it was moved? What do you think, Marie?
Would it again reflect over the y-axis,
Okay, reflect.
but also move right too?
Right 2, left 2, something. Okay, so let's check it out. Before we said if we were subtracting 2 on the inside, that was kind of the opposite of what we think, right? And it would move to the right. Let's see if that's actually what happens. So we're going to have the square root, and on the inside, negative x minus 2. Did it move to the right too? No, which way did it move? It moved left, right? You see how that beginning point, it's not at the origin anymore. It's now left 2. All right, so here's kind of a discussion point here. Typically, we said that if we subtracted 2 on the inside, it moved to the right. But notice how we have that negative x, which is affecting that transition, that movement. So what's actually happening is that negative is changing the direction. If the minus 2 would typically move right, that negative is now changing it to moving left. You got to be careful. You know how like a double negative makes a positive? Okay? You have that negative in there, it's going to switch the way it moves. So if we reflect it over the y-axis, it's now pointing to the left, and we have to move every point left 2 spots. So the origin point is now at negative 2, and we can draw in the other 2 points. Right, so you got to be careful with that negative on the inside. It's actually changing the way it's shifted. What about the next one? Can we describe the transformations? How it was moved? Good, Marie? All right, reflect y-axis because we have that negative x. And typically adding 2 on the inside would cause it to move left 2, but since the x is negative, that's changing the direction. It will be moving right 2. Right, so very similar graph that we had before, just instead of moving left 2, we're going to move it right 2. We doing okay? All right, so now that we have all these little pinpoint transformations, if we do this, this happens. If we do this, this happens. If we do this, this happens. We're going to get really good with identifying, based off the equation, what the transformations are. And once we can identify those, we're actually going to apply it to the graph. So let's see if we can check out the first one on the left down below. Based off that equation, can we describe or list, okay, what are some of the shifts or changes or flips or stretches that is happening to the square root graph? Let's see, we have a 2 in there, we have a negative x on the inside, we have a +1 on the inside, a -3 on the outside. What are all those numbers and negatives doing to a graph? Can we go one by one? Pick something. What do you think, Rebecca?
In front of that,
Uh-huh.
that will stretch the graph like further.
Okay, so vertical stretch. We're doubling the height. We're making it taller. Good, Evan?
Negative x, we'll flip it over the y-axis.
All right, y-axis flip. What about some of the other numbers? Good, Marie?
Well, 1 minus 3 negative 2, so we don't move
Say it again.
Will it move left to if we divide one?
So I see you're doing the 1 minus the 3, right? But notice how the 1 is specifically on the inside, so that's doing something. It's okay. And then the 3 is on the outside, so that's doing something different.
Then with the one make it move right one.
Right 1. Okay, so typically it would move left. It does the opposite of what we think, but we also have that negative on the inside, which changes the direction. All right, so right 1. And then what about the subtraction of 3 on the end? Good, Hannah?
It'll move like 3 down on the y-axis.
Down 3, yep, that y-axis movement. Okay, so we have all these transformations that we're going to try to apply to the basic parent function square root graph. Now, there's a particular order that we have to apply these in, and that's when it can get a little tricky. So I wonder at the bottom of the page, we're going to write down the order. And it's not that tricky to remember, but trying to keep track of all these transformations can get a little tedious. I just want you to remember RST, okay, like the alphabet, RST. We always do reflections first, so any flips. Then we're going to apply any stretches. Are we making it taller? Are we shrinking it? Okay, anything like that. And then lastly, we have those, they're called translations. That's the left, right, up, down movement, the shifting. Okay, so RST, just like the alphabet. Reflections, stretches, translations. So how I want this to go, if you have multiple colors available, that might not be a bad idea. If you have a pencil available, maybe you want to do some erasing. There's different ways that you can approach drawing these graphs. Okay, but we're going to do this one without a calculator, because now that we identified the transformations, we know exactly how the graph should be changing. What we're going to do is we're going to start with the original parent graph. So we're going to draw that original square root. Okay, I'm going to label that P for parent. Now if you're using colors, go ahead and choose a different color, because now we're going to transform this graph by applying one of these transformations or changes. The first transformation we should look for is a reflection, and notice how we identified one of those, right? We said we have a reflection over the y-axis. So we're going to take all of these points from the parent and fold them over to the left-hand side. I'm going to label that one R for reflection. Now at this point, let's say you're just using a pencil. If you wanted to erase the parent function, you could, because it no longer matters. This reflection graph is the new one that we're going to be using. So if you're using colors, you're going to have a bunch of different graphs on your paper. If you're using a pencil, you can kind of erase as you go. It's up to you. Okay? Our next transformation are any stretches. So notice how we identified a vertical stretch of 2. So on this reflection graph, we need to double every height. Now the beginning point has a height of 0. The next point has a height of 1, so doubling it would go to 2. And the next point has a height of 2, so doubling it would go to 4. I'm going to label that one S for stretch. Okay, we're making it taller. If you're using a pencil, you can go ahead and erase the R graph, because we don't need that one anymore. Now the S one is the important one. Alright, and our last order are the translations. So we're going to move every point on this S graph, right 1, and then down 3. So the beginning point, right 1, down 3, would be somewhere right there. The next point, right 1, down 3. And the next point, right 1, down 3. Okay, so you see how for colors it might get a little jumbled because you have a lot of different graphs, but at least you could see what you did each time. Erasing is a little bit cleaner, but by erasing you lose the previous graphs that you did. Okay, so there's pros and cons to both ways. Since this is the last one, you could label it T because that was your translations, or maybe you want to label it F to represent the final. Okay, that's your final graph that you have. Now, if we wanted to check this to make sure we were correct, okay, let's say you had a graphing calculator to check your work. Let's go ahead and type in the equation 2 square root negative x plus 1 on the inside and then minus 3 on the outside. Doesn't the graph we drew look very similar to the one on the calculator? Okay. So we're graphing functions by hand based off these transformations that we can identify. Are we doing okay so far? Am I going too fast, too slow? All right, let's check out the next one. Can we identify any transformations? Shifts, stretches. Go ahead, Hannah. All right, we have a reflection over the x-axis. Anything else? Minus 1 inside, plus 3 outside. What do you think, Marie? Did you say left one? It would move right one. Okay, again, the inside is tricky. Typically, the minus would move right. It's only if we had a negative on the inside that would change that direction. And notice how this one doesn't have it because the negative's on the outside. Okay, so the placement of these negatives is important. Okay, good catch though. Brianna, did you want to do the last one? Up 3. All right. So let's go ahead and draw the original parent square root graph. Those are the beginning points that we're going to utilize. All right, now our order, R, S, T. Did we label any reflections? We said x-axis, right? So we're going to take all those points and fold them over the x-axis. We're now going to be in the 4th quadrant. Next is S. Did we label any stretches? Any stretches? I'm seeing head shakes. No? Right? Okay, we didn't label anything vertical stretch, right? All right, so that's one good thing because that's one thing less that we have to do. What about translations? Did we label anything left, right, up, down? Yeah, okay, we have 2 of those. So all of the points on this red graph, we're going to move right 1 and then up 3. If you wanted to label that T for translations, that's fine, but since it's your last one, you could also label it F for final. Okay, maybe we'll check and see how we did. We can do negative square root on the inside x minus 1, and then plus 3 on the outside. Looks very similar, right? Okay, so if you have a graphing calculator, you can check your work, but do you notice how most of these you don't need it, right? It's all based off of the transformations. Shifting left, right, up, down, flips, stretches, all that good stuff. We doing okay? All right. I think we're going to stop there for today. Okay, I know we have a few minutes left, but I really want to make sure on the next page we can fill out this chart in its entirety so we can start to see some patterns. So we're just going to wait for that for tomorrow. Okay?